right, first two examples from these notes are you try it, so I'm going to scroll past those in case you want to try and check with the key. So example 3, sketch the graphs of x equals 3 and y equals -5. So these are your special types of lines because they don't fit the slope-intercept form of a normal line. So if we're looking at sketching the graph of x equals 3, the only thing that is required is that x must equal 3. So if I'm going over to my graph here, if x has to equal 3, I could be on this point, that's 3, 0. I could come down here, that's 3, -2. 3, -1, I could come up to 3, 4. As long as I'm on 3, it does not matter. So what that means is the equation of an x equals value is going to cross the x-axis at whatever number you were given. So in this case, 3. So x equals a number is always going to be the equation of a vertical line. So this is x equals 3. Y equals -5. So again, it still doesn't fit that typical slope-intercept form because we're missing the mx plus b value. So when you're given y equals and just a fixed value like -5, we're going to get the horizontal line. So everything's going to align horizontally. So the line y equals -5 is going to cross the y-axis at the given y value. It's not wanting to cooperate very well right now. So we'll get our arrows on. That's crooked. So here's your line. Y equals -5. So remember, x equals is always a vertical line. Y equals just a number is always a horizontal line. And then there's your reminder. We did already discuss the types of slopes they have, but a horizontal line has a slope of 0. Vertical line has an undefined slope. So there's the rest. We can read through discussing perpendicular and parallel lines. All right, find the equation of the line that passes through the point 4, 5 and is parallel to the given line 3x minus 6y equals 7. Write your answer in. We're only going to be doing the slope-intercept form. Your notes have had the point-slope form wiped out. So just slope-intercept form. So first thing I got to do is figure out, I've got the point 4, 5. I need the slope. So it needs to be parallel to this line that we are given right here. Parallel lines have the same slope. So what I need to do is I need to figure out the slope of this line I am given so that I can use the same slope. So to do that, I'm going to pull my equation, 3x minus 6y equals 7. And we just want to take this and rearrange it to slope-intercept form so we can see the slope value. So we're going to subtract 3x. So -6y equals -3x plus 7. And then we've got to clear our -6. I'm going to divide everything. Remember, you don't just divide one, you divide the whole term, on all terms on both sides. So we wind up with y equals 1/2 x minus 7/6. All right, so now that you have your equation that was given rearranged into slope-intercept form, we know we need the same slope because it says parallel. So I am going to pull the slope here. A parallel slope, I usually use the symbol for parallel as a subscript on the slope, which is like two little lines that look parallel. So the slope we want to use is going to be the exact same as 1/2. So now I'm going to go take my slope that I need, 1/2, the point I was given, 4, 5, and we're going to go to point slope form. So I'm going to scooch this over here so that it's kind of oriented a little better. All right, so we have our point 4, 5. We have the slope we need, which is positive, I believe. Yes, positive 1/2. So we're going to point slope form. Y minus y1 equals m times x minus x1. So y minus my y value of my 0.5 equals my slope value 1/2 times the quantity x minus my x value of my 0.4. So we have y minus 5 equals 1/2 times x minus 4. So then we were told to write our final answer in slope-intercept form. So now I'm going to rearrange this to slope-intercept form. First thing you have to do, distribute your 1/2 to your x, so 1/2 x, and to your -4. So that's -4/2, which is -2. Then we're going to move our 5. So we wind up with y equals 1/2 x minus 2. So here's our equation. All right, example 5. Find the equation of the line that passes through the point 3, 2 and is perpendicular to the line 2x plus 3y equals 4. And again, we're just going to write it in slope-intercept form. So, perpendicular to the given line, perpendicular lines have what are called opposite reciprocal slopes. So I need the opposite reciprocal slope. So before I can even worry about what that is, I need to figure out what the slope of the given line is. So our line was 2x plus 3y equals 4. So 2x. So this was the line we're given. So I'm going to rearrange it to slope-intercept form, just like the last one. So we have 3y equals -2x plus 4. We are going to clear our 3 by dividing all terms by 3. So we wind up with y equals -2/3 x plus 4/3. So once you have your line rearranged, you need to ID your slope. So the slope we are given is -2/3. A perpendicular slope is an opposite reciprocal. So I like to use the symbol for perpendicular because it's a large word. The symbol for perpendicular looks like an upside down capital T. So the perpendicular slope, opposite means change the sign. So the given slope was negative, so our slope is going to be positive. Reciprocal means take the number and flip it over. So our value was 2/3. We are going to flip it to 3/2. So change the sign, flip the value. So then I'm going to take my perpendicular slope, which is 3/2, and my new point, 3, 2, to get my equation. So we have our point, and we have our perpendicular slope. And we're going to take these two things and go to point slope. That's how we have to start in order to get to slope-intercept. So point slope, y minus y1 equals m times x minus x1. So y minus my y value of 2 equals my slope, 3/2, times x minus my x value, 3. And then we're going to take this and rearrange it to slope-intercept form. So we need to distribute our 3/2. 3/2 x minus 9/2. And then we're going to add R2. So we're going to get, barely have enough room, 3/2 x. And then when we add 2, you got to get a common denominator. So we've got a -9/2 plus 2, -5/2. All right, next one says determine whether the given lines are parallel, perpendicular, or neither. It also says to give a reason. If it asks you to give a reason, you've got to give some sort of explanation. So the easiest way to determine, as far as lines go, they can be either parallel, meaning they never intersect each other. They could be perpendicular. Perpendicular lines means they intersect at a 90-degree angle, or they can be nothing. If they don't do parallel or perpendicular, we're not worried about what they do. So parallel lines have the same slope. perpendicular lines have opposite reciprocal slopes. If there's no comparison between those two, then we're left with the neither option. So what we want to do is identify the slope of each of our line and then just compare them to see if it fits one of the scenarios. So our first line, y equals 4x plus 1, is already in slope-intercept form. So we just need to ID our slope. So the slope of our first line, so I'm going to call this line 1, so I'm going to call this M1, is 4. If I go to my second line, it is not in slope-intercept form. The easiest way to find the slope is just to rearrange it. So I am going to move my x over. So we have 4y equals negative x plus 4. I am then going to clear my 4, dividing every term. So we have y equals negative 1/4 times x plus 1. And then I want to ID my slope here. Slope's always the number in front or the coefficient of x. So slope 4, we're going to call this line 2, or I'm going to call it line 2, is negative 1/4. So I take my two slopes and I just need to compare them. So first off, I'm looking at them. They are not the same number, so therefore they are not parallel. So then I need to check perpendicular. Opposite means opposite signs. Our first slope was positive. My second slope is negative. So they are opposite. Then I check reciprocal. The slope of 4, which if we think about as 4 over 1, if I flip that over, I do get 1 over 4. Therefore, these slopes are opposite reciprocals of one another. So the lines are perpendicular. So lines perpendicular. And I'm going to put since for my, because it did say to give a reason. And I'm simply just going to, I've got all my algebra up here. So I can just say the slopes are opposite reciprocals. All right, our second one, B. We're doing the same thing, we just have two new lines. So first one is already in that slope-intercept form, so we just want to ID our slope. Our slope is the coefficient of x. Draw a box, please. Nope. It's been in a mood today. One more try. There we go. All right, so I'm going to call it line 1, which means this is slope 1, negative 2. Then I go to my second line. It is not in slope-intercept form. I need to get it there. So we're going to move our 8x. So I have 4y equals negative 8x minus 6. I clear my 4 by dividing all terms on both sides. So I get y equals negative 8 divided by 4 is negative 2. And negative 6 divided by 4, negative 3 over 2. And then we look at our equation here. Our slope is, I'm going to call it line 2. So slope 2 is negative 2. And then we compare them. They are clearly the same number. Therefore, our lines are parallel. So I'm going to put lines parallel. Since slopes are the same. So if you compute your slopes or get your slopes and compare them, if they are not the same and they are not opposite reciprocals, they are classified as nothing. They're just boring. So there's those two. The rest of the examples on here are you try it's covering what we just went over. So feel free to work those out and check them with the completed notes to double check your answers.